Hi everyone! Today we're diving into the fascinating world of string transformations. Imagine you have one word and want to change it into another. Maybe you want to correct a misspelling or find the shortest way to morph one word into another. These are the kinds of puzzles we'll be solving. String transformations are everywhere in computer science. They help us with spell checkers, DNA analysis, and even in those cool voice assistants we talk to. By understanding how to transform one string into another, we unlock a powerful set of tools for solving all sorts of problems. So, buckle up, word nerds. We're about to embark on an adventure in string manipulation. And trust me, it's going to be fun. Let's get started. To explore the fascinating world of string transformations, let's imagine a fictional high-tech machine called the X9091. Picture it as a sleek device in a futuristic lab, ready to take on any challenge you give it. This nifty device takes your instructions, almost like magic, and applies them to a string, transforming it into something entirely new. Whether you want to tweak a single letter or completely overhaul a word, the X9091 is up for the task. The X9091 understands three simple yet powerful commands that let you control exactly how your string changes. The first command is delete, which removes a character from the string. We represent this operation with the letter D. It's like erasing a letter with a single press. Next we have insert, which adds a character to the string wherever you need it. We use I, followed by the character to be inserted. This command lets you build up your string, one letter at a time. And finally there's change, which replaces one character with another. We use C, followed by the new character. It's perfect for making quick corrections or updates. These three commands, delete, insert, and change, are the essential building blocks of all our string transformations, just like pieces of a puzzle coming together. By combining them in clever and creative ways, we can transform any string into any other string, no matter how different they seem. The possibilities are endless, and the process is both logical and fun. Pretty cool, right? In the next section, we'll put the X9091 to the test and watch it work its magic with a real step-by-step example. Imagine you have the string ABCDE, and your goal is to turn it into BCGFE. This might sound tricky at first, but with our trusty X9091 machine, it becomes a fun and straightforward process. The X9091 is designed to handle these kinds of string transformations with ease, making what could be a complex task into something almost magical. To make this transformation, we need a specific set of instructions. Here's what we'll use: D, IG, and CE. Each of these commands tells the machine exactly what to do at each step, and together, they guide the string from its starting form to the final result. If you're curious about how these instructions work, let's break them down step by step. Understanding each command will help you see the logic behind the transformation. First, the instruction D stands for delete. It removes the first character, which is A, from the string. Now we're left with BCDE. This is the crucial first move that sets up the rest of the transformation. Next, IG means insert the letter G right after B. So after this step, our string becomes BCGDE. This insertion adds a new twist to the sequence, bringing us closer to our target. Finally, CE tells the machine to change the letter D to an F. Now the string reads BCGFE, which matches our desired output perfectly. Each instruction plays a key role in the transformation. With just these three simple instructions, we've completely transformed a BCDE into BCGFE. It's amazing how a few well-chosen steps can make such a big change. The X9091 makes these kinds of string transformations not only possible, but incredibly efficient and even enjoyable to experiment with. But here's the real challenge. How do we figure out the best, most efficient set of instructions to transform one string into another? That's where the true power and creativity of the X9091 comes into play, and where things get really interesting. While transforming strings with the X9091 is fun and can feel a bit like solving a puzzle, there's a deeper layer to this challenge that makes it truly fascinating. The real challenge lies in figuring out the most efficient set of instructions to get from one string to another, especially when the strings are long or complex. Given two strings, how do we determine the fewest number of deletes, inserts, and changes needed for the transformation? It's not just about making random edits. It's about finding the optimal path that saves time and effort. This is where the concept of edit distance comes in handy. edit distance is a powerful tool that helps us measure how different two strings are and what it takes to make them the same. Think of edit distance as the shortest path between two words in the world of string transformations. It's like navigating a maze, where each move brings you closer to your goal. The smaller the edit distance, the more similar the two strings are. This concept is used everywhere, from spell checkers to DNA sequencing, whenever we need to compare or correct text. Finding the minimum edit distance and the corresponding X9091 instructions is a classic computer science problem, and it's one that has fascinated researchers for decades. And luckily for us, there's a clever technique called dynamic programming that can help us crack the code. With dynamic programming, we can break down the problem into smaller, manageable pieces, making it possible to solve even the toughest string transformations efficiently. Imagine each string as a point in space, and the edit operations, delete, insert, change, as steps you can take to move from one point to another. The edit distance is then the shortest possible path between those points. Why do we care about this shortest path? Well, in many applications, each edit operation might have a cost associated with it. For example, in a spell checker, replacing a letter might be cheaper than inserting a new one. Finding the minimum edit distance helps us find the least expensive way to transform one string into another. In the next section, we'll learn how dynamic programming can help us compute this edit distance efficiently and systematically. Get ready to unleash the power of algorithms.